Okay, so what we're going to title on page 5, we're going to title this as ordering real numbers. Ordering real numbers. And today's date is 9/16. So right underneath the title, you're going to put that sheet I gave you with perfect squares and perfect cubes. You need to actually memorize those, because the big problem that you're going to run into if you don't recognize what's a perfect square, you have a lot of trouble. So you do need to go through those and make sure that you know them. You won't be able to use your spiral during a test or a quiz or a real quiz. Homework quizzes, yes, but during real quizzes, no. Okay? So here's a prime example of a homework assignment you might be given tonight. They're going to give you a list of numbers, and your job is to place them on the number line. So what do you think the problem is with ordering these so that you can get them on the number line? What do you notice about the numbers that might make this a challenge the way things are written? Julia?
They're not all written the same.
Yeah, they're not all written the same. You got something with a radical, you got a decimal, you got an improper fraction, you have a mixed number. So what form do you think would be best to put all these numbers in order to figure out where they go on the number line? Jacob, what do you think? And what does that mean? How are we going to simplify them? Because I have two options to go. I could either go all fractions or I could go all decimals, except for that runs into a problem with the square root of 20. Can I write that as a fraction? No, because remember it's an integer over an integer, and that would give me a radical 20 over a 1. That doesn't help me at all. So what's the best way to convert them all so that I could get them on the number line? I hear some whisperings. What do you guys think? I'm hearing more whispering. Say it real loud, Vincent. Oh, he's so loud when he says loud. Decimals. I think decimals are going to be our best bet. So we already have one that we can put in. So 4.7, if this is 4.5, I'm going to say 4.7 would be there. So I'm going to make a mark here for 4.7. And I can label it. Okay. What would I do with 12 thirds in order to figure out where to put it? What am I going to do to figure out how to graph 12 thirds? So nobody should be gluing anymore. We should be done with gluing. Okay? Yes?
I'm writing 12 by 3.
We're going to take 12 and divide it by 3. Now most of us recognize this as a math fact from like 3rd grade, right? So 3 goes into 12 exactly 4 times. So that's pretty convenient. I get to mark that. Oh, go away. Right there. I hate it when it's not pretty. There, that's as best as I can get. Okay? So let's try the next guy. 4 1/3. Now, a suggestion was made in first period. Rewrite that as an improper fraction and do long division again, just like we did on the 12 thirds. However, there's a simpler way to do this. I already know that this number, 4 1/3, is going to have a 4 in the front as the whole number. It already told me that. So instead of wasting my time making an improper fraction and then doing the division, all I need to do is convert the fraction part. Okay? Now, many of you already know what that fraction is because you're familiar with the certain fractions and their decimal equivalents. So what is the decimal equivalent of 1/3? 0.3 repeating. So again, we could do the division. 1 being divided by 3, put in the decimal point, add a 0. 3 goes into 10 3 times. 3 times 3 is 9. Difference is 1. Add another 0. And what you see is you're going to keep getting 3's. So we can say this is 4.3, and we can put the bar, not the bar. The reality is I need to graph it, so I'm going to say it's about 4.3. So this was 4.5, that middle bar, so 4.3 is going to go about there. So we'll put 4.3 here. Let's I'm going to do that a different way. When I label, I like to go back to the way it was given to me originally. So I'm going to draw a line here and say that's 4 1/3. And then I forgot on the blue guy, he is 12/3. So the problem now comes, those are pretty simple, right? The problem comes with how do I figure out where the square root of 20 is? Okay? So I'm going to show you an exact way, and I'm going to show you a more general way. Okay, and I'm going to find a couple videos from YouTube, and I'll also attach them to our homework so you guys can watch those and kind of get the use of it. Because sometimes we don't have to be too specific, and sometimes we need to be. So I'm going to go ahead, and at this point, you guys should have been following along and writing down what we had, right? Because that's part of your job. And so I'm going to pause this. Okay, so here's what we do. That sheet that we glued on becomes extremely important. In order for us to estimate the square root of 20, we need to figure out where it would fall on the number line. So we're going to start really globally. And the first thing we're going to ask are, what are the two perfect squares, listen carefully to those words, perfect squares, that 20 falls between? So you can look at that chart if you don't know. What two perfect squares, Desi? Okay, what I need to know is what is 4 squared and what is 5 squared. So I'm looking at the number that's under the radical sign. He's called a radicand. So I'm trying to figure out the two perfect squares that 20 falls between. So I'm looking at 16 and 25. But 20 isn't standalone. 20 is under a radical sign. So I need to do the same thing to 16 and 25. So then we answer, well, what does the square root of 16 equal? What's the square root of 16? 4. And what's the square root of 25?
5.
So right now I know my numbers between 4 and 5. That's not enough information because every single number on that number line fell so far between 4 and 5. Where exactly does it fall? So this is where I have to do my next step. My next step says, okay, is my number closer to 16 or is my number 20 closer to 25? So I do a couple little quick subtraction problems. 20 take away 16 is 4. 25 take away 20. I'm always referencing back to my number is 5. What that tells me is my number is slightly closer to the 4 than it is to the 5. And the reason why I use the word slightly is because the two differences were very close to each other. So now I'm going to estimate a number closer to 4 than to 5, but kind of in the middle to guess to see what is going to be closest. So this is called guessing and checking. So I'm going to pick 4.4. and I'm going to multiply it by itself. So I'm going to square it, because remember we're dealing with perfect squares here, so we have squares we're contending with. So I need to see how close this number is to 20. So 16, 16 and 1 is 17, placeholder, 16, 16 and 1 is 17. I have a 6, I have a 13, I have a 9, I have a 1, I had 2 digits after the decimal point. 19.36 is just below 20. So then I have to see, well, what would the next one look like? So I'm going to go the next higher number, which would be 4.5. And I do the math again. So I get 25, 20 and 2 is 22, placeholder 20, 16 and 2 is 18. 2 digits after the decimal point, and I get 20.25. Now, in order for me to determine which one is closest to my goal number of 20, I do subtraction again. So 20, take away the first one, 19.36, and I get 64. And then on this one, the one next to him, I get 20.25, take away 20, and I get a difference of 25. Which one of those had the smaller difference? Okay, so this guy. So what that says, remember we had the smaller difference was 4. That's why my front number, my digits were closer to the 4. This difference says this value here best estimates what the square root of 20 is. Okay? Now, honestly, the best answer is going to be somewhere between 4.4 and 4.5. But for our purposes, we just need to go to the nearest tenth. So we're going to say that the square root of 20 is approximately equal to, it's not equal to, because I'm rounding, so that's the squiggly marks mean approximately equal to 4.5. So now I can go back to my list of numbers, and right here at that halfway mark is where my square root of 20 will fit in. Okay? So that is one way to do the estimating square roots. I'm going to show you one other way. And I'm going to include the video for this one, okay? So this one's a little simpler, but it's not as accurate, and you'll see when I say that in just a second. So it starts off exactly the same way as our first strategy, where I figure out which two perfect squares the radicand 20 falls between. I take their square roots, and I know the numbers between 4 and 5. Now, I know my number can't be 5 something, it's got to be 4 something, so what I do is I grab the 4. And that's going to be the first part of my answer. But I want to know how far from 16 and before I get to 25 am I on this list. So this strategy says you're going to add, so always a plus, and what you're going to do is reference back your number to the smaller number. So what I want to know is what's the difference between my number and the smaller square root. And I'm going to put it over the original number. So the original number shows up twice over here. Okay? Then I simplify, and I get 4, and I get 4/20ths, and I simplify. I get 4 and 1/5. And now I try to figure out what 1/5 is. So I do my division, and it goes in twice evenly. So I get that answer is 4.2. Is that the answer we got when we did it the guess and check way? So this is a quick one, but if I'm really nitpicky trying to figure out where it goes, the first strategy is your better strategy. Now, I've got a worksheet to go with the homework that's from your textbook for your homework tonight.